is streams or roads, but this is roads, and I remember from the LKA is always roads. The LKH is your streams, so that's your stream file. And so you've got a variety of files in here that we downloaded. Now note that some of the files that they ask you to download, the place files, for example, they're going to vary in completeness depending on where you are. And the same with the locations, the geographic locations and the point data. Sometimes, and I haven't checked this in advance to see if it includes the fire stations and things like that, like their file that they used included. Hopefully it will. But just to let you know, sometimes that place information varies depending on where it's coming from and the effort that was put into generating that. So, but one of the other reasons I like to preview things is I can look down in the lower right at my coordinates down here, and it's a good clue, a good indicator of what projection this data is in. After you work with the GIS data quite a bit, you'll get used to the numbering scheme. And if we did not know the metadata that we already found out was in geographic NAD 1983, from this view alone, without knowing that, we can tell that it's geographic by looking at the coordinate information down here. We've got a -84, which is our longitude, and then 35 for the latitude. Any of the other types of coordinate systems that you might use, like UTM or state plane or so forth, that number would be much larger than this, for one thing. So it's pretty easy to tell if it's geographic right away. Sometimes it's a little more difficult to separate UTM from state plane, but geographic really pops out. So we know our projection is going to be geographic. The next question we have, now we don't know if it's NAD 83 or 27, so that's important. Now they did tell us it was 83, so we know that about this file, but just from looking at this view, I'm saying we don't know what datum that's in. So we would need that information, and if you don't have that information, should you download a file for your project later on or something like that, and you don't have that information, but you've went this far and you can see that it's geographic, then usually it's safe to assume it's in NAD 83 and go ahead and assign that. Hopefully you won't run into that case. Hopefully you'll have the metadata to where you know what it is. But if you absolutely don't have it and you're having to figure it out on your own, then you've got to make some assumptions. And so we would have assumed that, and then we would hope it would line up with other data that we might brought in which case if it didn't, then we'd know one of those was wrong. So anyway, we know this is geographic, and we know from the metadata it's NAD 83. Now the next question is has it been defined as that? And just like we've done before, we're going to check that. And this again is a little bit different than the exercise article. Back in the earlier version, I kind of liked it, some of the features a little better. They had a nice extra tab up here that would let you look at your metadata, and it was really really handy. I thought it was really user friendly, and that's gone now. And so we've got a little bit of a different way of looking at it, and there's more than one. But the way we've been doing it is what I'll do here, and that is to right click on the file name, and we'll go to properties, and then we'll make sure you check the coordinate system tab and see if it says unknown. If it's unknown, then you know it's not been defined, in which case we're going to need to define that. And so we know that we're going to need to define actually each of those layers. So because none of those are defined already, we can spot check a couple of them and see that that's the case. So it's a little bit of work on our part, but it doesn't take too long. And I'm going to do a couple of them here, and then I'll pause the video and I'll go through and do the rest of them. But I wanted to show you a little bit of a shortcut that some of you may have seen in some of the other videos, and some of you may not. So let me go ahead and we'll define the first one. We'll we'll select that, not double select it, just one time. Then we'll start our toolbox, which takes a minute to pop up. So I'm going to pause the video while that's popping up. Okay, mine finally opened. The first time you open Art Toolbox in a given session, it always takes a little while to open, and sometimes longer than others, depending on your computer type and speed and how much other things you have open. I know mine seems to get slower and slower. So we have this open, and we want to go to our data management tools, and we want to go down to projections and transformations. And then we want to define projection, which Most of you have done this so many times already, you're used to this, but for the few of you that have not, will appreciate this, I think. And we'll go ahead and we can add this layer. Again, we can click the file folder and route over to the folder location and add it, or we can simply drag it and drop it, which I like to do because it's a little quicker. It loads that file, and as it loads it, it's getting the information about that file. And after several seconds or so, it will pop up. And it tells us again that it's unknown, so we know that we do need to define that coordinate system. So we will, and if this box is not open to the right, I have mine open by default. You've got this show help. I like to have that open to remind me when I'm working with different utilities about some of the steps I need to follow. So for the coordinate system, we'll click the little box to the right. It brings up our spatial reference properties dialog. We will select, and in this case, we want to go to geographic type of coordinate system. So we'll click the first one twice. And since it is it's geographic, it's in North America, we will click North America. And we want to click the NAD 1983 projection. And we don't need to, there's other 1983s in there, just ignore those for now. I'm just scrolling over so you can see those. Just click the one that says NAD 1983 with nothing after it. We'll add that, we apply, say OK. That puts it in our dialog, and we say OK to accept it. And you'll see in the bottom, and I'm not sure if it will show up in mine because I'm using two windows. It might show up in the other window, but you usually on the bottom area of your screen, right in here where I'm circling with the mouse, you would notice a little scroll bar that says defining projection. And once it's finished, there'll be a little dialog box pop up in the lower right-hand corner, and that's how you know it's finished. And again, mine's doing it on the other screen, so you won't see that here on this video, but that's what's going on. And it takes it just like it took a few minutes for the ARC toolbox to open. The first utility you run takes a few minutes to finish. And once you've done the first one, the other ones will go more quickly. And it is actually popping up in the bottom of my dialog here where you can see it. So it's defining the projection, and in a minute you'll see a little box pop up in the lower right saying define something like define projection. And you see my preview went away, but my define projection box did pop up, but it was on the other screen, so you can't see that. My preview went away because things changed with that file, so ArcGIS would have to regenerate that preview. So I'm just going to switch that back over to the Contents tab to avoid that popping up again. And now we can go ahead and define our next file. So let's click on Define Projection again. We'll drag the second file in there and drop it. And instead of having to go through the entire dialog of selecting, I'm going to import, and I'm going to do this the first time. After I've done this once, I won't have to do it again on this session. But I'm telling it the folder location where the file was that we just defined, which was this first one. So I'm going to click that and add. And what that does, if you notice, it basically just adds the same projection. A PRJ file is actually stored already in ArcGIS, and it's basically just going and pulling that file over whenever you assign or select a projection. And once you've done it for one file, you can basically just, what we're essentially doing is saying, hey, let's use the PRJ file that went with the first one we defined for this file as well. And you'll see here the third file, you'll see how it does help a little bit on time. We'll say OK, and we'll click OK. And this time it should define much more quickly. And mine has already finished. Again, the dialog's over in the other window where you can't see it. So now we can go to the third file, and we'll drag that in, and we'll do the same thing. We will import, and this time it remembers the folder location, so I'll just click that first one for each of them because we know that first one was defined. And click OK and let it run, and it does that one. So I'm going to pause the video while I do the rest of them, but you'll find if you do it that way, it saves you a few clicks and speeds things up by a little bit. Just a note, whenever you drag and drop files in, if you accidentally forget where you left off and you drag one that's already been projected again, let me do that so you can see how it looks. It will, instead of saying unknown, it will have the coordinate system and a little caution icon for you. that basically tells you, hey, you've already defined this file. So if you forget where you've left off in the process, then just go ahead and drag it in anyway and look at it, and if it gives you the caution, you'll know that's the last one in the list that you defined. Okay, I've done all of my files, defined all of them now, and I know that's a little bit of a little tedious process to go through there, and there are other companies and other individuals that have created script files and such that will give you some shortcuts for doing certain things that are repetitive in the ARC programs. And one of them I used to have was a little button that I could click on at the top of my screen, and it would let me basically set a projection for every file in a certain directory. And it was really handy because in cases like this, you could basically use the time it takes to define one file and define all of them, as long as all of the files in that folder were of the same projection. And if I find that utility was, I had it with an older version. Now, if I find it and find that it's been updated, I'll share that information with you in a future date. But go ahead and define all your files, and once you're finished with that, we can start pulling them into ArcMap. So let's do that now. First, I'm going to close Arc Catalog so that we don't have them both open at the same time. And as soon as that closes, I will open ArcMap, and I'll pause the video while I get that open. And while ArcMap is open, I wanted to point out just a couple things here. In the article, it lets us know that we're going to be setting our projection. We're going to define a projection for our data frame in the new ArcMap to be in state plane 1983 feet. Now they're using California, so be sure if you used a different area that you use the appropriate states state plane region for yours. But I just wanted to point out that a lot of times you'll find local utilities and local agencies like to use a state plane projection. We've tended to use either geographic or UTM in a lot of our work. And it's important that you get used to using state plane as well. So it's a good exercise in this article for that reason as well. But also later, when you do some analysis and things on the data, you'll find that some of them will not work unless your ArcMap session is defined in one of the projected systems. So geographic basically will not always work when you're trying to do certain analyses. So that's another good reason to make sure your ArcMap session is set to a state plane or a UTM. And in some cases, you'll find you can't do analysis unless the data has been projected into one of the coordinate systems. So in other words, geographic is not always the best for doing analyses and things. But in this case, we'll follow what the article is doing, and we'll go ahead and set our data frame up to be state plane 1983 in feet, and we'll use Tennessee this time. Let me move the ArcMap view over to the recording window here. And remember that if we just pulled a layer in here without defining the data frame, then the ArcMap project in this data frame in particular would get set to whatever projection we used for the first layer we pull in. So it's sort of an automatic way of ensuring that a projection gets established, but we don't want to set it in geographic 1983. We want to set it in Tennessee State Plane 1983. So we'll manually do that like they instruct you to in the article, except we're using Tennessee instead of California again. And we'll go to right click on the data frame, which is called layers in this case, and click on properties, and we'll click on predefined, and instead of geographic we want to go to projected. We want to go down to state plane, and then we want to go down to NAD 1983 in feet, US feet. Make sure you click that one. Note that, let me close this. There are several other 83s in there, so make sure you get the one that's NAD 1983 US feet, and then just scroll down until you get to Tennessee. And luckily for Tennessee, we don't have but only one state plane projection for the entire state, so that makes it a little easy for us. We can select that, click apply, click OK. And if you notice, the coordinate system down here in the lower right went from geographic looking type of numbers that said unknown units to uh, a little bit larger set of numbers, but still not as large as what you would see with UTM data. And this is our state plane data, and it's in feet. So now we can go ahead and load our layers, and I'm just going to go ahead and load all of them at once. And I want to make sure that it remembers the folder, and it did. So we are in the correct folder. So we can select these by clicking the first one and holding the shift key down and clicking the last one and clicking add. And that will add all of our layers at once. We get kind of a busy map here at first that we can then clean up a little bit and change some of the properties to make it look a little better. And looking back over at the article, I noticed that I like that the author has you save your map right away. We just added data in our case, and in this case they didn't even add the data yet, but right away it's a good idea to save your project for a couple reasons. One, that protects the work you've done thus far if it should accidentally crash or something happen. And two, it makes it easier to save sort of on the fly in the future. So once you've saved it, then you can just click on this save button in the future to resave it. So as you're working, try to remember to periodically click the save button, and that way, so should something crash unexpectedly, you wouldn't lose the work that you've done up to that point. So I'm going to click on Save As this first time because I want to specify where I want to route it and the name I want to give it and so forth. So we will route it over to our 220 folder again, just like we've been doing. And in this case, I'm going to keep it here in the root of the class EX2 folder, and that will make it a little easier. It separates it from the data, and I don't have a project subfolder, so I'll just put it in the root of my working folder of class EX2. And switching over to the article again, you notice he asked you to save it as SLO01.mxd. So let's do that. We'll SLO01, and it adds the MXD for us. So we can just say save, and that way we'll have a project in here. And now anytime we want to save as we're working, we can simply click on the save button and it will resave that. And you can see the name up here in the top left. And as the first step in cleaning up our project a little bit, you'll notice in step 4 here he mentions to rename your layers based on the names in figure 1. And when I do it, I'm just going to, for example, he's using landmark points, and then he has the tiger after that. I'm just going to call mine landmark points because we're just dealing with one county in this case, and so I don't see the need for having to put that other part of the name in there, and it takes up less space and saves a little bit of work. So let's reduce the size of this a little bit so we can see them together in the same screen here. Let me enlarge this part. And I've rearranged my windows so that you can see both of them at the same time. And we want to make these basically the more obscure names here to match sort of what we have over here under data layer. So we'll start with using our codes here. Let's just start at the top on this side. We'll work our way down, and we're looking for the one that's LPT1. And looking in this list, LPT1, it looks like it's a number 1, PT1 here. We've got landmark points. So we will change this to landmark points. Notice the way I rename that is by clicking once on the layer and then pausing a minute and then clicking again, both with the left button. That highlights the information in there and lets me change the name. Now we've got LKA. We look on our list here. LKA is line features roads. So I'm just going to call it roads instead of line features roads. Again, this just saves some space over in my table of contents and doesn't make it take up or steal away as much from my map content in order to be able to see all of it. So that's the way you rename those. And also note that we're not technically renaming the file itself. What this is doing is just renaming the name of the file for our purposes here in this project. If you right click and look at properties, for example, the one we just renamed to roads, then you'll see that it still has the base file name. It doesn't change the file itself. I can click over into the general and you can see I've renamed it layers here. But if I go to source and look at the file and the file name, then you'll see that it still is, scroll over a little bit there, you see that it still is called the Tiger 47035 LKA. So it doesn't change the actual name in the file, it just changes it for our purposes, or viewing, and makes it visible. And that's another way you can rename the files, is instead of doing the clicking twice, you could right click on one and go to properties and click on the general tab and you could rename it there as well. It's just a little easier to me if I just do it this way. I think it's a little bit quicker. So go ahead and proceed down the list doing that. I'll pause the video while I'll do that on my end, save some time. Okay, we've now renamed the different layers using the key that they had in figure 1. And again, I didn't include all the detail that they had. I shortened them just a little bit, but they make enough to make sense here. So you can kind of tell what layers they are. And again, remember that we've just temporarily renamed these. They're not, the file names didn't actually change. So this makes it a little easier to know what we have in terms of layers. And then obviously the next thing you would want to do in most cases is go ahead and set your symbology such that your map is a little easier to interpret. Right now it's very busy and it's just using all the default symbology, which, as most of you know, ArcGIS is terrible about picking default symbology. So what they do in the exercise, let me see if I can pull it back up here. In the exercise, they eventually have you encourage you to use some of their layer files that they had with some sample data. I did not post the sample data, and I'm assuming most of you have not went out and tried to find that. If you did, that's fine. If you did, though, you probably found, like I did, that it doesn't work. So that's the reason I didn't mention that. What you can do instead is go ahead and create your own symbology, and then you can save that into layer files of your own, and we'll talk about that in a minute. But what they do next in the exercise is have you join the CFCC data over to these different layers. Now the CFCC data, they explain more about it in the article, but it's very valuable information. I think I mentioned this earlier, but we have, let me see if I can pull it up here so you can see what it looks like. Okay, this is the file that I uploaded for you on our Momentum site. And this is a sort of a cleaned version of the one they talk about in the article. So I'll show you it in just a minute for comparisons. But you can see this one only has 2 columns of information, the CFCC code and a description field. And this is what's valuable about this table is you get individual detailed records for each of the CFCC codes, or at least most of them. There are some that they don't, they're like temporary for future use, but a lot of the codes and all of the codes that's included in this file have a description out here in this field. And just scrolling through it, you can see there's lots and lots of information in there. So and they're grouped around the categories. You see there's D, it begins with A, and that's road related. And then we move into the B numbers, and those seem to be railroads and things like that. And we move into the C's, and there's not so many of those. And the C's seem to be just sort of like a miscellaneous kind of category. And in the D's are one of the more detailed ones, and these contain just a whole variety of things that are probably related to feature locations. You know, we've got golf courses, cemeteries, government centers, schools, and things like that. Then we have just a few E's, and they seem to be like physiography kind of features with mountaintops and ridge lines. The F's are often like some kind of a boundary, administrative boundaries, statistical boundaries, things like that. And then we get in, it jumps from F to H, and H are your water features. And you can see things like perennial, canals and ditches, reservoirs, things like that. And then finally, they've got an X00 for features not yet classified at the end. Now again, mine has 192 records in it, And the one mentioned in the article does exist on their site, and I'm going to switch it over just so you can see that. It's similar to what I have, except they have a couple extra columns. The one is a speed limit column, and this is more relevant if we're working with network analysts, which we may do a little bit with that a little later. So I'll save this. I'll go ahead and post this on our website so you'll have it as well. And you could use either one, but really there's nothing in here that you need that you don't have in the one I posted. One of the reasons I created the other one is because in their version there's a lot more records. They've got 471 records, but if you get to looking, a lot of them are codes that are unspecified. So it's like fillers in a way. You've got these codes that they can use for future entities. And so, there's a lot of unspecifieds, and so I just cut all of those unspecifieds out to make it a little bit easier to deal with. So that's the main difference. And these other columns, I'm not sure what display really is. I've looked at it and tried to get a handle on it, but I'm not positive what display really is. And then just FCC is seems to be the same thing as CFCC. I don't know why they've included that in there. So there's reasons they've done that for their own use. The only ones I saw that we really needed was the description, which they had cut the title off there. And so I just sort of customized this file a little bit, and that's the one I uploaded for you guys to use. Either one will work, but again, you have a lot of these unspecifieds and such in here. So that's the main difference between the two. So on ours, the CFCC table, assuming you use that one, it's also an Excel file, whereas the other one is a DBase file. And the Excel, of course, just loads by default. The DBase file, you have to remember to change your file type when you're trying to load it in Excel, if you do try to use that one. So what we want to do next is join each of these layers to the CFCC code table, because each of these layers contain unique CFCC codes for the data specific to the county we're working with. So let's first open a few of those up just so you can see that. The landmark points file, if we open the attribute table for that, that's the only point file we have, by the way. And let me move it over here. And you can see here they've got CFCC codes. If we expand this a little bit, if you scroll down it, you'll see they all begin with D. So you know that the D CFCC codes go with the landmarks. And the name field, most of the records are pretty empty. If we sort this table by right-clicking on that header and sort it in ascending, we can see that most of the records are blank there. And at the very end, they have a few with names. And so we do have a variety of features. We have one governmental type place with the post office, and then we've got one church that's named. We've got looks like a camp, some kind of a camp, and the airport, and a medical center, and a nursing home. But by far, out of these 257 records, most of them don't have a name with it. So we don't really know much about those places, and this is going to vary from one county to another. Some counties are more complete. It just depends on the people that were involved for putting the data together or submitting the data probably to the Census Bureau from that county. And here in Cumberland County, apparently they didn't include much of the name information. So some of that you would have to pull off of other sources if you really needed that, like a topo map or phone directory or things like that. But you sort of get what you get when you download the data from directly from the census. It's just the information that they had. But what's important here is if we join this to our CFCC code table, we can pull over the description information for each of these CFCC codes, and we could then symbolize our layer by the description information instead of CFCC code, and it will be much more descriptive of what we have in our legend. So that's what they're doing in this article, to try to get at a little more complete information. So looking at a couple other layers, if we look at the hydrography, open that attribute table, you'll see there's more information in there. The name field, which they call FE name, tends to be a little more complete. There's still blank records, but you have definitely a lot more data in the hydrography information. And they have a little bit more of a topological information in here too. That's with the from address to address for now, just ignore those. Those all tend to have zeros in them anyway, so they're not completed in here. They just had a place for them, and since they were numeric, they've defaulted to 0. By the way, a little tip, and this comes up some from time to time.